So today the topic is oscillations. So coming to the introduction. So basically we have three types of motions. In that the first one is a periodic motion, and the second one is oscillations, and third one is simple harmonic motion. Okay. So we will discuss one by one with examples. So coming to the definition of periodic motion, it is defined as if an object moves in such a way, that is, motion get repeated after a fixed interval of time, then the motion is said to be a periodic motion. Okay, so the best example is uniform circular motion. So look at this diagram. So this is the circular path. There is an object of mass is m which is revolving around the circular path. Okay, so let us assume this is the initial position of the particle. So I am writing here, this is the initial position of the object. Okay, now the object starts moving with some velocity v in a circular path and moving like this, and finally reaches the same position. Suppose for one revolution it takes 1 minute time, means for second revolution also it takes same 1 minute, again for third revolution also it takes same 1 minute. So that's why the motion is uniform motion or uniform circular motion. Okay, so the time taken to complete one revolution must be equal to the time taken to complete the second revolution. Okay, so these type of circular motions are called periodic motions. Okay, now coming to the second one, that is oscillations. Coming to the definition, oscillations also a kind of periodic motion, but it is bounded between two limits. Okay, so the best example is a simple pendulum. So this is the black diagram of simple pendulum. So there is an object of mass m which is connected through a massless string, and this position is called mean position, right? So that is already you know. Suppose if I pull this object up to a certain limit with some force, and then if I release it, means what will happen? This object will move towards A and reaches to this point A, again coming to the point B, again moving to the point A, again coming to the point B. Like that, the object will oscillates between two limits A and B. Okay, so here A and B are called extreme positions. So this type of motion is called oscillations. Okay, now coming to the third motion, that is simple harmonic motion. Okay, basically this simple harmonic motion is also a type of a periodic motion, but the object need to be a straight line path. We are representing the motion of the particle is looks like a straight line path. Okay, so coming to the definition, if an object moves in such a way, that is the acceleration of the body is proportional to its displacement from a fixed point, and its direction is opposite to the motion. So coming to the explanation, so look at this diagram. Here A and A dash are called extreme positions or two limits. Okay, initially the object is located at point O. So this O is called mean position. Suppose if the object is at rest state, means the net external force acting on the particle is 0 and displacement also 0. So at mean position, displacement x is equal to 0. If the displacement is 0, means net force acting on the particle also 0. So force acting on the particle also 0. So F is equal to 0, where at mean position. Okay, now let us assume the object starts moving towards A dash direction, along forward direction. Okay, so whenever the object is moving along forward direction, definitely acceleration was developed in this direction. Now after 1 second, suppose this is the position of the particle. Okay, again for next second this is the position of the particle. See, whenever time interval was increases, the object moving forward direction with some acceleration a. So this acceleration, that means whenever the body is moving forward direction, displacement increases in backward direction, right? Again for third second, the position of the particle is here. The displacement will be maybe 3 meters. Okay, so like that, whenever the acceleration was increases, displacement also increased, but whatever the displacement was increased here, this increasing displacement is opposite to the acceleration. That means acceleration of the particle is forward, displacement will be increasing in backward direction. Okay, so whatever it may be, that acceleration of the particle is directly proportional to the displacement but negative. Okay, where negative sign shows that, negative sign indicates that acceleration and displacement both will be opposite to each other. Opposite to each other. Okay, so I'm going to remove this proportionality constant. For that I'm taking a is equal to minus omega square into x, where omega square is constant. Okay, so this is the introduction of oscillations. I hope you understand. Thank you. Thank you so much.